Hey, everybody. Really excited to have you all here and to get to introduce Ginger Allington. And so it's an extreme pleasure to have her hosting her here today. As you'll see, she and I have woven in and out of one another's lives in a number of locations around the world and co-mentored one another and supporting through both the ups and the downs. So it's so fun to have her again, not too far away. So she's coming to us as an assistant professor at Cornell University. I first met her in St. Louis when she was a grad student, and I was a very young faculty at the time and taking courses and navigating the St. Louis scene. So she got her PhD at St. Louis University and then went on to a postdoc in Michigan, and from there to CSYNC, the Socio-Environmental Synthesis Center in Annapolis, Maryland. And then she came to George Washington University, where I was also a faculty, and she was a faculty in geography. And then about 3 years ago, she moved to Cornell. So it's a fun trajectory where a bunch of places in the country we've been around one another. And so Ginger, when I met her, she was a landscape ecologist working in arid systems in the Southwest US. As she progressed, she's increasingly added on human dimensions. So thinking about the coupled influences of climate change and management and policy and how that affects landscapes and landscape function. And so she's worked in a number of places in the world, the US, Mongolia, Asia more broadly, and then starting some new projects in Brazil. So I'm really excited to introduce Ginger and thank her for coming here today, and looking forward to her talk. Thanks.
Thank you, Amy. It's so fun to be here with you. The last time I was at the Cary campus was about 20 years ago, so it's nice to be back, and your buildings are very fancy now. So I'll kick on. So I just wanted to start with, as Amy said, I started a little bit of an eclectic research program. So I just wanted to position that a little bit, and this is a very boring slide, but I didn't have time to make anything more fancy. Really the central question that unifies a lot of the work that I do is trying to understand how individual decisions about landscape management kind of scale up to landscape impacts. And I come at that from a lot of different angles, depending on the project and depending on the partners on the project. But usually it's some combination of scaling up ecological assessments, kind of field work to remote sensing, and then thinking about, if we want to understand landscape scale change, quite often we need to start asking questions about people and how are people making decisions about how they are managing those landscapes. And so increasingly been bringing in more and more social science approaches and social data into our work, and really thinking a lot about sort of the governance of commonly held natural resources. So that comes through a lot in my rangelands work, but is also kind of a through line to some other work that I'd be happy to talk with folks about that's looking at pollinators and forest structure. Not going to get into that today, but flag me if you want to talk about that. This also involves a lot of different kind of modalities and epistemologies. So thinking about field work, bringing in satellite data. We do a lot of modeling in terms of trying to bring those pieces together. This isn't going to be a particularly modelingly heavy talk in terms of the integrated modeling, although there's a little bit of remote sensing, but a little bit more of a straightforward project that we'll talk about today. So just kind of exemplifies this underlying question of what are the drivers and consequences of land degradation in rangelands. I've been working in rangelands for about 15 years or so now, and I really, I love rangelands as a system, but also I think they're just a really important ecosystem that relatively is understudied across the globe, right? We're talking about almost 40% of the global land area, livelihoods for billions of people, forage for the vast majority of the world's livestock are in arid and semi-arid rangelands. And they receive, I would say, much less attention than some of their treed partner landscapes. And they're near and dear to my heart. And they're also, like many ecosystems around the world, facing a lot of extensive degradation due to various combination of factors, including climate change, but also sort of decisions about land management and stocking. Been flagged by numerous reports, and actually next year, 2026, is going to be the International Year of Rangelands and Pastoralists. And those two things are very coupled, rangelands and pastoralists, because they have kind of co-evolved together, right? Pastoral livelihoods really developed as a way to deal with the inherently highly variable environment that we find in semi-arid and arid regions. We have patchy distribution of rain, and in a given year, a high variability from year to year in precipitation that's driving underlying vegetation productivity. And so mobility is really key in these systems. If you're raising food for your family, trying to do that in one place year after year is not going to work, right? You've got to be able to move to where the productivity is growing in that particular year, in that particular season. And so that is one of the reasons why we see pastoralism as the livelihood strategy in semi-arid systems. And because you can move them, right? You move with the seasonality. And as a consequence, rangelands really are these complex, coupled social and ecological systems. If we want to know really what's going on with the vegetation, with the grassland, with forage condition, we really need to wrap our arms around a lot of complex interactions between how is climate driving both the condition of those, but also decisions about changes in land use and land cover over time and over space, the movement of people, not just with their livestock, but also out of the region. And a lot of the work that I do on these systems is on the Mongolian plateau, both northern China and then Mongolia in particular. And Mongolia is a really interesting place to be thinking about these issues, because that's a really complicated, I guess, or like tumultuous cultural and sociopolitical history tied in with land access and land management, right? So we have this long, like thousands of years of kind of the development of pastoral livelihoods and the development of norms and collective institutions for managing those. Then in the 1960s, Mongolia was under Soviet control, not technically a part of the Soviet Union, but kind of highly under their control. Everything was really collectivized, and a lot of the traditional institutions were really formalized. And then that all kind of fell away in the 1990s, and there was sort of a vacuum, right? There was just a real huge loss of the institutional support that had been in place over the collective time, and then a huge kind of gap in the informal institutions that used to exist as well. And so there's been a lot of insecurity since then in terms of the development of formal regulations about who has access to what and when. Still a lot of mobility in many places and a lot of maintenance of the traditional norms around access and shared access and reciprocity, but also increasing competition for land between people and industry and increasing livestock, which we'll talk about in a second. So Mongolian rangelands are really taking a hit and facing a lot of stressors. One of the big drivers of change, especially in these sort of concentrated hotspots, is the increase in mining activity, extractive industries, which now is the dominant source of the economic growth in Mongolia. It's a huge booming industry, but this is competition for land in a lot of really rural areas. And then on top of this, and then also underlying changes in climate in terms of increasing temperatures, increasing heterogeneity in precipitation regimes, there's also an increased frequency in these severe winter weather disasters that are called ZUD. So zood is a phenomenon that has always occurred, but they're occurring more frequently, that come in basically 3 different themes. White zood, which is basically really intense snowfall, huge, such that livestock can't get through to the forage. Iron zood, which is basically snow and then rain on top of it, and then it freezes, and so basically blocks the livestock from getting access to forage, and then just extreme cold temperatures. And sometimes these 3 converge, and a lot of times these are happening after drought seasons. So the mortality rates are very, very high and in targeted areas. And so the most recent one was in the winter of 2023. There were millions of livestock, about 5 million livestock, that died just over a span of a couple of months across Mongolia. So this is people's livelihood, it's their savings, it's their insurance. So it's having a big impact on people's decisions about whether they're going to maintain these lifestyles. And so this is underlying another huge phenomenon happening in Mongolia right now, which is rapid rural outmigration. The population of Mongolia, a couple of million people, 2/3 of those live in Ulaanbaatar, the capital city. So extremely high density of the country's population within one city. And this is having a lot of impacts in terms of the urban sprawl and air quality and things like that. There's been a lot of focus on, the research has been on Ulaanbaatar, less so on the sending areas, which I'll get to in a second. But there's also a lot of conflicting perspectives on the status of rangelands in Mongolia right now. Competing papers coming out from competing research groups, competing narratives about what the drivers of those are, which we'll get to in a second, and a lot of interest in trying to understand what is the state of rangelands across this extremely vast area with a relatively low population density. And one of the challenges was getting a sense of the status of grassland condition. This is just from a national report funded externally, but done by the government. And all of these dots are individual sampling locations scattered around the country. The colors correspond to the level of degradation. And this is one of the major sources of information that people draw on as far as grassland condition. So there's a number of issues, right, with these kinds of data products and others, right? So if we've got the national report, we're taking point data, right, and trying to extrapolate across big areas. We know things are really heterogeneous. And so there's questions about how much you can say about broad areas of the Gobi Desert from 25 different sampling points across that vast region. Another big source of more broad-scale wall-to-wall mapping of vegetation condition comes from things like MODIS-derived vegetation indices, which are at relatively coarse spatial scales that don't necessarily correspond to the scale at which people are making decisions about how they're managing livestock. And then another big piece of information that people tend to use for understanding vegetation condition is just looking at things like vegetation indices over time, like simple NDVI indices, which are great for getting at greenness, sure. Oh, my top bar got all messed up. I hope this doesn't feed through the rest of my slides. But that greenness does not equal condition is supposed to be over with that other map. And so just this idea that, right, just because something is increasing in greenness, decreasing in greenness, doesn't necessarily tell us anything about underlying composition, forage quality, in terms of nutritional content, and also functional group composition, right? A lot of times, particularly down in the Gobi where we see things getting greener, it's woody encroachment, and so it's not necessarily palatable anyway. So there's a lot of information that we don't get out of metrics like that. Another challenge is that if we're trying to get finer resolution, particularly products that try to go from individual plot assessments up to satellite data. We've got error propagation right through time with any of these scaling steps. And then also, as we predict forward and backward in time, right, there are uncertainties about how applicable models can be when we're trying to apply them to slightly different climate conditions in a different year or over different areas that weren't sampled originally. Finally, another piece of uncertainty, which we're not going to get into the really solving this today, but I think is really worth flagging, are these big questions about what are the drivers. And this really is like tied in these big debates about equilibrium versus non-equilibrium systems, and trying to sort of pick apart to what extent are our changes in vegetation the result of overgrazing and livestock density versus climate drivers. And a lot of this, if you know anything about equilibrium versus non-equilibrium system dynamics, falls somewhere in between the two of these, but also falls into sort of thinking about what part of the country are you looking at. But a lot of the assumptions about non-equilibrium system dynamics, and so thinking about these drier sites where typically climate is a stronger driver of productivity than grazing. A lot of those models are based on an assumption that mobility has continued, that if conditions are poor, herders are going to move their livestock somewhere else, that there is no supplemental fodder coming in, right? This idea that, oh, well, it's just gonna, we're gonna sort of be able to move around to these other areas. Mobility is key in that assumption. So what's going on in Mongolia livestock-wise? Rapid growth. So this is from the 1970s up to 2023, and so the bars here in blue are those severe winter weather disaster years. So you can see dramatic losses of livestock over a year or two over those winters, these little pulses, but then rapid increases again in livestock after that. Some of this is driven by those losses, right? The livestock are the insurance against future disasters, and so the restocking as a way to basically buffer future losses. And there's been another really significant shift in terms of the herd composition, with a number of goats really rising, and they have different and significant impacts on forage conditions compared to things like camels or cattle in terms of their grazing behavior. So rapidly increasing livestock over time, but at the same time, the number of herders is declining, So on the top graph here, this is broken down into different areas of the country. Most of my work is in the Gobi and in central Mongolia. We'll talk today about that dark line. So we've got, generally speaking, right, declining number of herders, increasing number of livestock, right? And we know that outmigration is a huge phenomenon happening in Mongolia. So there's very little known about how this rural outmigration, this rural depopulation, and the loss in the number of herders, how that might be changing the demographics and the labor availability for herding this increasing number of livestock. It becomes harder and harder to move, to be nimble, the more livestock you have, and particularly if it's like an older generation that's sort of staying behind. And so this is a big question that we had within some collaborators and I that kept coming back around to. And so we were successful in getting some money from the NASA Land Cover Change Program to try to think about this, to try to take a look at this question that no one's really been looking at in terms of what's going on in the rural areas. And so we kind of had two main objectives. One, to try to get some finer resolution maps of vegetation that got us at something besides just greenness, and really trying to get at something that could capture vegetation structure over time. So not trying, for various reasons, not trying to get the sort of golden prize of explicit functional group, although that would be amazing. We're still kind of working on that and parsing that. there are reasons, and we can talk about that, why that's challenging in Mongolia. But trying to at least get something that gets us at some structural changes that might be happening with heavy grazing and shifts in community composition. And then also asking what are the changes in labor in these rural areas, and how is that changing anybody's herding behavior, the way that they're kind of managing their livestock. And then trying to tie that together, how are these changes, potential changes in mobility, impacting the spatial temporal patterns of forage availability? Because you can imagine, right, if you have more livestock, you're moving less, it's kind of constraining the scale of grazing impact over smaller areas, but then also potentially, right, leaving farther flung areas with lower grazing intensity. So there may be some spatial patterns in terms of the degree and the sort of direction of change over time. So we set out to look at this in the central steppe region of Mongolia. That little cutout in the middle of Tuve province is Ulaanbaatar. And so we're looking across a stretch of 3 different provinces in central Mongolia, specifically tying our data collection to the central steppe, so the sort of classic grassy steppe region of this area. Looks like a very small piece, but it is about 60,000 square kilometers, so a relatively big area, just a small part of overall Mongolia. And along with this, so we did a bunch of social data collection, meeting with agricultural administrators and doing some kind of key informant interviews with them, a series of almost 200 household surveys with herding families across 8 different, essentially like counties within these provinces, and then a series of focus groups as well, getting a bunch of herders together, doing a little bit more like free-form jazz social data collection. And then for the vegetation data, we were basically stratified the region by soil type and by the overall direction of change in terms of just looking at trends in NDVI. So kind of starting with that. Are there areas that are green or areas that are getting less green? Just using that to stratify things a little bit. Set up a series, a distribution of 50 sites that are kind of distributed across, stratified across these regions. And for this work, and I won't get into all of these today, this particular work stream was really driven by these 3 different questions about how asking kind of, trying to get at whether we could improve the plot to satellite-based vegetation assessments by basically plugging a drone in between and developing a 2-step approach to mapping vegetation, where we can take advantage of the rich data at the plot level, but we know we can't cover very much area with plot-based assessments. And so can we scale that up with drone data and then use that as a bridge up to the satellites? So I won't get into all the various steps of that, but I'll touch on it a little bit as we go on. So we're collecting, a little grainy, sorry, UAV overflights over each of these 50 sites across these 100 meter by 200 meter plots with a series of half-meter square vegetation plots where across a transect in the center where we're collecting data on vegetation height, cover, functional group composition, things like that. So from the drone, this is animated apparently. Yeah. From the drone data, we're able to gather on kind of 2 different data streams, right? So we've got the orthomosaic that we get from all of the images kind of stitched together. And then also develop some structure from motion point clouds to get a little bit at the structural component of the vegetation. This is very low stature vegetation. We're talking 15 centimeters. So we were actually not sure that this was going to work at all, and we were delighted that we were able to get some pretty good signal out of that. So we developed some models from both from the UAV data, drawing from the spectral data from the orthomosaics, and then the structural data, use that to try to predict our ground vegetation data. And then, and did an okay job at that, I'll say. I took the slide out where I show you the okay predictive power of that. But we just kind of wanted to see, can we get them to talk to each other? Are we capturing what's here? But the real thing that we wanted to do was to see if we could slot those predictions in to a pipeline that we could use to tie into Sentinel data, predictive Sentinel data, and get a wall-to-wall map over our entire study area. So we're kind of feeding, right, the UAV data and the predictions from there, and extracting information both from the UAV and then also the satellite data. So we end up right with this, actually this is probably shown better in the next slide, two sets of kind of data streams coming into this, right, coming out to the UAV and then up to the Sentinel data. And from the Sentinel data, because we've got data over time, we're able to get some land surface phenology metrics that we brought in to sort of try to disentangle some of the compositional pieces that are have different phenologies over a growing season. So we had this one-step approach, right, where we went right from grassland to satellite. We ended up with 294 samples because over the alignment, right, of a pixel kind of over, is not one-to-one necessarily with our ground plots, even though these are 10 pixels. And then we have our two-step approach where we're going from the grass to the UAV and then to the Sentinel data. So we've got the same number of UAV estimated vegetation cover and height estimates there. Mandatory error assessment and cross-validation information. Happy to talk more about this later, but I don't really want to get into it right now. I think we'll just pop right to the sort of take-home piece. So what you're looking at here on the left-hand side are the one-step models where we've got vegetation cover on the top, vegetation height on the bottom, and this is our one-step model, right? So we have, I would say median to low quality ability to predict with these, and then a really drastically improved ability to estimate vegetation characteristics when we go from the UAV up to the satellite. So putting that in the middle in between. And we're really pleased that actually we were able to maintain this estimate of vegetation height from these satellite data that aren't getting us any of that structural, or none of those structure from motion kinds of information. Want to mention another piece of this that I think for the more wonky modeling folks in the room just might be interesting, and I'll touch on it briefly, and we can talk about it more afterwards if you want to. So one of the things that we were really interested in is thinking about how does this two-step approach kind of scale through time? Can we use this we have data from 1 year, right? Our field data from 1 year. But we have now access to the satellite data where we have a temporal, right, signal. We got to look at change over time potentially, but how well are we going to be able to do that? And also thinking about we have a lot better coverage with these UAV footprints, but that's still just small slices of the overall landscape, right? So we have these questions about sort of how well are we sampling the overall variability across the landscape with our individual UAV scenes, and then also how well are we capturing the sort of temporal variation over time. So there's sort of two kind of standard, so there's a general standard approach for doing cross-validation, is a sort of stratified approach where we're going to have some sort of some sort of takeout of training versus testing data for every single one of our plots and use that to try to predict, right, what's going on at one of the other sites. This does a great job at kind of capturing, right, the range of things that we have sampled with our UAV sites, but kind of could potentially constrain our ability to predict to just that realm. So we took another approach, which is called the leave sites out approach, where we're basically like taking all but one site and using the data to try to predict something that we don't have any sample data from in our training data, right? So how well can we do at predicting conditions in a site where we haven't trained on any information from that site? And then we also were thinking about this idea of area of applicability. There's a great paper by Myers and Probezma a couple of years ago, really driving this home, that we really need to think about what's a realm of conditions, what's a realm of signal of the data that we have, and if we're trying to extrapolate out to new areas, to additional areas, how well are those represented in the data that we have, right? So sort of thinking about this, but over broader scales. This idea of how applicable is your work to these other realms. So generally speaking, right, a stratified approach works to kind of decrease your model error, right? You're building a model, right, with information from all of your sites. So your ability to predict is usually a little bit higher than in the leave sites out approach. But the leave sites out approach gets you the possibility to potentially be able to predict into a broader range of space if you're trying to extrapolate out, because you're not just so constrained only to the conditions that, or as constrained to the conditions that you have considered. And so we developed area of applicability masks for all of our different geographic regions and for each year over time, and did some comparisons. And so here we have just a comparison of the leave sites out cross-validation compared to the stratified. So you can see, again, right, we have more error and our predictive power is less with the leave sites out, which would potentially suggest, right, that we would want to go with a stratified cross-validation approach. But the thing is that we have a much lower ability to predict over a broader area of space when we're using a model that was cross-validated with a stratified approach. So we can only actually predict 63% of the region as opposed to 95% of the region with that leave one site out approach. So really trying to think about, okay, well, what are the trade-offs here, right, in terms of our ability to predict? So those are cover estimates up there. Here's our height estimates, right? 96% of the area versus 60% of the area. And so there's really this trade-off, right, in terms of what are you trying to go for? You're trying to have as high as possible of sort of predictive power for the sites that you know that you can predict to, or you're trying to make some broader generalizations, right? And when we look over time, so this is vegetation cover and height estimates in the triangles and circles, and then this is the comparison of how much of our area, our study area, are we able to predict to or for over time with these two different approaches, right? So we have a much higher ability, not just within 1 year, but also over time in terms of our ability to project out into other space and generate these wall-to-wall maps. So that's generally what we ended up going with, was this leave one out. Perhaps a belabored point, but I think it's important for us that those trade-offs, right? We go with this like stratified approach like really off the bat all the time, and we have to think about what are we compromising in terms of our ability if you don't actually compare it to something else, and people are rolling those out over space, but if you aren't taking that area of applicability into account, then you're potentially predicting into space that you have really no business for your model to be predicting into. So we ended up with a series of maps for this whole area for vegetation cover and vegetation height over each of these 5 years that we were looking at. And then we're able to put obviously those together to get some maps of trends. And then we also decided to put these together since we were so happy with our vegetation height estimates and our ability to capture these trends. And you'll notice, right, that the trends in vegetation cover and the trends in vegetation height are not necessarily telling the same story. Right? We see different spatial patterns in terms of where are things getting better, where are things declining, where are things increasing versus decreasing. There's potentially different drivers at play here, and really behooves us to think about both of these. And so we also developed a vegetation volume layer where we could try to sort of put those into conversation with each other and get at sort of a 3D construction. Just wanted to flag that we put all of these together for our entire study area into a series of reports. And just this past month, we did a sort of tour of administrative offices, taking wall maps and these reports that have maps for every individual county, and took these out to meet with the agricultural administrators, get their feedback, and sort of deliver these products to them. So here's just an example for one area, one of the counties. And you can really see, right, how they're very, this is cover, height, and volume in that order, and really different spatial patterns in terms of the trends. One of the things that we provided in these reports, and its example is down in the right-hand corner over there, was just basically a plot of the trends in these metrics over time. These are aggregated to the entire county, and there's actually quite a bit of change in this particular county compared to some of the other ones. Most of the lines look a lot like B on this across all these metrics when we look at these aggregated averages or medians that we have here. And so we lose a lot, right? So we present this to them and it's like, oh, well, there's no change, right, in vegetation height across your entire county for these years. Well, they know that is not true, right? But also the maps will show us this too. And so I think I belabor this point. It's like not obvious or not, it's not rocket science to anybody who spends a lot of time looking at maps, but I think a lot of modeling and a lot of statistical methods work with these aggregated data, right? And we're saying, okay, well let's just get a general estimate of what's going on at this particular place at these relatively large scales, and it really obscures the much more highly refined spatial variation over these areas, and at the scale that people are actually experiencing the landscape and seeing changes. So I just think it's a really good illustration of how we have to be careful when we're sort of building models and aggregating up about sort of how are we representing some of this. And one of the big questions we actually had going into this was that there may be changes in spatial aggregation of vegetation parameters over time. And we're actually still in the analyses stage with that. But I just wanted to throw out a little bit of a teaser of one of the ways that we're looking at this. And so these are just some initial results on looking at the sort of scale at which vegetation, and this is for height estimates, are the scale of spatial aggregation and how that has changed over time. I'm also including this because in one of the first classes I ever took with Amy was an our class grad seminar where we had to share methods with the other students, and I presented about how to do a semi-variogram in R. And so I found it very funny that somehow is still a part of my life. But basically what we do with a semi-variogram is trying to understand what is the distance at which pixels or points are no longer autocorrelated, right? What is the scale at which we see these sort of spatial aggregation? And so generally speaking, right, we're seeing a decline, not across all of them, but a decline over these 5 years in the scale of spatial autocorrelation in vegetation height. Again, this is aggregated across the whole. But this is taking points, pairs of points from pixels across the entire county. And worth noting that we're kind of landing at around 200 meters there, which if you've ever, which I would assume no one has, because who else has ever done this besides me, looked at semi-variograms across a range of semi-arid grassland degradation trajectories, a very pristine, so we call it, good condition grassland usually has a sill somewhere around a kilometer, 2 kilometers, kilometer and a half, something like that. That usually corresponds a little bit more to biophysical gradients than to any sort of spatial patchiness, because things are so heterogeneous. And so this to me pops out as a potentially really drastically low number, low scale of aggregation, but we're digging into this and looking a lot at patch metrics right now. And I was hoping to be able to talk and have amazing results of that, but the computers are chugging away as we speak. But potentially really interesting things happening in terms of the spatial aggregation as well. So this is like the technical mapping stuff, right? And we did present this to the folks there in these ag offices, but that was only one part of the project. And so over the last couple of minutes that I have, I want to talk a little bit, bring us back to the social dynamics and what we were learning about how people are actually managing these landscapes. And I'll say just a caveat, the plan was, so here's our study area in the red and blue, and these outlined or labeled counties are the ones where we were doing household surveys within this area. And the plan was, because we had those distributed across these counties, to be able to take the spatial data on where a household was, put a buffer zone right around that, and generate some information about what was going on with the vegetation conditions around individual households. That was our plan. Go to the households, do the surveys, get some information based on where they were located. However, that winter was a Zood winter. And so we were not able to get to all of the individual herder households. And in fact, it is much more difficult to get around in a four-wheel drive vehicle than it is to get around on a horse in this landscape. And so instead, a lot of the households came to us into centralized locations, which was great for actually getting the social data, but terrible for getting the spatially explicit survey information. So we lost out on our ability to really tie individual household responses to individual locations on the landscape. So all we can do is sort of think about them at the aggregate. We have these aggregate assessments. We know what county they're in, even what equivalent of like a township they're in. So we can aggregate them in that way. But again, we lose a lot of the nuance about the spatial variation when we do those aggregates. And so, we're trying to figure out the best way to get at that right now. But we did still learn a lot of really interesting things about what's going on. So let's just go through a few of those really quickly. So first of all, just, our objective was try to understand outmigration, and so we did in fact find that it is actually happening. So that was, we knew it, but it was in the data too. There are some interesting things in terms of the demographics of who is experiencing outmigration in terms of who is left behind, right? And what is the potential labor left in the household. So for migrating households, well, actually across the board, the average age of herders is getting older. There are younger herders returning in some places. These two dudes in the center are two examples, but for the most part, the age is getting older. And so I'm just going to do some broad statistics here so you can look at the pictures instead of showing graphs. So about 62% of them said that outmigration is changing the household labor available for managing livestock. And that they've had to change how they manage livestock as a result of that loss of labor, right? They're not able to do everything they used to do in the same way. And really importantly, and this came from our surveys, but also from talking with the administrator, the agricultural administrators, people are moving less. There's typically the sort of classic situation would be to move 4 times a year to different seasonal camps, and that is averages now is to about 2 times per year. So people are staying longer in individual areas. That's concentrating grazing pressure in individual areas. It's a general decline in how much they are moving. And then herding is increasingly motorized, so a lot more use of both motorbikes and then also moving these basically little huts on wheels and sort of parking them and staying for longer periods. Also, herd composition is shifting, which we kind of see from the aggregate trends, but we also see from the graph from before, but we saw it in our data as well, and this real emphasis on increasing the number of goats and sheep in the herds. And this just has implications for how you manage them, right? Having hundreds of goats is a logistical situation that's different than having some free roaming camels or something like that. And across the board, herders were indicating that there's growing tensions between their neighbors and outsiders that are coming to access pastures. There's a long, thousands of years long history of granting access to outsiders if conditions are poor where they're coming from. And, but this is happening more and more, and people are staying for longer when they do come. So this is starting to erode that trust between people and their sense of sort of being willing to extend that. Then another really, we were not set out to ask about this, and so we actually have some follow-up surveys that we want to do, but across the board, really high interest expressed in fencing as an adaptation for declining pasture conditions. Fencing is extremely uncommon in Mongolia. It is relatively socially unacceptable, but is sometimes historically used for setting aside small areas for reserve for the winter or things like that. But a lot of times historically those were not fenced. But increasingly people are wanting to do that. It can be an important tool for pasture restoration for keeping people from grazing in particular areas that you want to recover. But the administrators we talked to have been reporting that some households are fencing much, much larger areas than in the past and starting to go and fence large areas of the common grazing areas. And this is typically more affluent herding families that have the money to build fences and put them up. There are actually no explicit laws against fencing in Mongolia because everybody just didn't do it. And so there's actually some requirement if the government goes out to remove fences that have been put up, they have to repay the herder who put them up in the first place to sort of recoup those losses. So it's actually working against the administrators who are interested in that. So about 46% of them of the households are either currently fencing or considering doing so in the future. This is a shock to everybody that we worked with. It's just I can't understate how unusual this was, and the implications for that are potentially really huge in terms of segregating the landscape and changing access and the sort of movement of people. However, about half of those people felt like the cost was just prohibitive. They just didn't have the resources. I would fence if I could, right? If I could do that, if I had those resources, but I just don't have access to it. And also feeling like it's kind of socially unacceptable. It's going to kind of ruin the mojo with my neighbors. But this is a growing area of concern in Mongolia in general because of the extensive fencing along some of the rail lines that has been disrupting wildlife movement. And so if the scale of that and if the patchiness of that fencing starts to spread across broader areas of the landscape, that's going to not only impact wildlife, but also just the ability of herders to kind of adapt and be mobile and move from place to place, and could further kind of restrict the areas of high grazing pressure to smaller areas. So just one more thing I wanted to mention from these that kind of ties it a little bit back to the the remote sensing data on, so just drawing from the areas that we know we can have high confidence that we can predict to, we see actually that the perceptions don't necessarily match with the overall trend or the overall cover conditions and height conditions. So if we look across the entire region, right, we see actually the median cover is higher in 2023 than 2019. Vegetation height is also. But again, right, that overlooks the really high spatial variability in these trends. And so just to make that point again, that like when we look at these sort of broad area metrics, sometimes we are glossing over the sort of lived experience of folks on a particular part of a landscape if we're just making these sort of generalizations over the top of them. So I think I'll just tie up with a couple of few points. Here's a couple of photos from our meetings with these ag administrators. Again, you can see we had these big wall maps out, and one of the great things about putting these maps out on the table for folks to kind of huddle around and sort of talk to each other is we got a lot of really great community input on these maps. And so while I'm like insanely frustrated about our inability to link individual households with individual locations on our maps, to a certain extent, the stories that we got are like sort of a very good consolation prize on that, where we have folks, right, pointing at a map, like he is the administrator for this region of this particular state, and he knows who lives in that particular area, right? And so what some of the stories we heard were about this area right here, where we see a lot of declining trends in vegetation volume. There are 3 separate, very wealthy herding families here that have on the order of 3,000 to 5,000 head of livestock. They are not moving. They are there. They're doing supplemental fodder feeding to get their herds through the winter, and you can see where they're at on the landscape. This guy, he's hiding in this picture. The guy with his arm behind him and the blue and white stripes, we called him, they called him the steppe gardener. He is very particular about how he cares, his herd size and his mobility and how he's managing things. His camp is located in this blue area here of high increasing vegetation conditions. All anecdotal evidence, but wonderful like experience to be with folks on, have a map and have them say, this is me here, I can see what I'm doing. And then just a final piece, that this whole area over here is an area where there was a bunch of outsiders who came in during the last zood and haven't left. And so starting to see, they're quite interested to see the impacts here and to be able to take these actually to a follow-up meeting with other folks from the government to talk about actual strategies for this region, and they were able to take that map with them. So a couple of take-home points. So structure is important to monitor, right? It tells us a different story than just cover and greenness, and that we really need to think about how we are aggregating some of these spatial data to actually better match the scale at which people are actually experiencing these landscapes. And then just to point out again, these emerging themes around fencing and the declines in mobility that really might be driving some of these spatial patterns that we see. And with that, I want to just thank a huge team of people on the ground and my amazing collaborators, in particular, Ryan Blackburn, the postdoc who did the lion's share of the UAV work, and then Anu Dari, who also did a lot of work on the vegetation modeling as well. And I will take questions, but while I do that, I'm not going to leave my question slide up. I'm going to leave up this QR code, or you can go to this link right here, which will take you to a Shiny app where you can interact with some of those maps and do some summary statistics and things like that. Thanks.
All right, thanks very much, Ginger. So I'd like to open it up for questions.
Really fascinating talk, thank you.
Thank you.
I was wondering if the overall increase in what looks like well grass height and cover versus the perception of a declining is to do with, and I think maybe you're saying this, like increased concentration of where the grazing is happening, but then where it's not happening or where it's happening less, like CO2 effects on grass growth.
Yeah, that's the like, oh, sorry. So the question is, could some of that disparity between perception and sort of overall macro scale increases in cover and height be due to some potentially spatial separation between where that perception is happening and where the perceived decline and the increase? And that is the sort of working hypothesis that we're trying to nail down with some of these spatial statistics in terms of trying to, the thought is that we actually will trying to disentangle those, the scale of autocorrelation across the trends and thinking about, do we see different, essentially, spatial patterns in the declining conditions versus the increasing conditions, more diffuse in the improving conditions and more concentrated at small spatial scales in these declining conditions. Yeah, and that's what's coming out. I just don't have like shiny figures for it yet. Yeah, great question. Yeah, Dan.
It was an awesome talk. I was just wondering, it looked like when you had those county breakdowns of spatial autocorrelation, there were a few that jumped out with really steep regressive slopes. I know you didn't get the household data for like, oh, is this immediate area someplace where people are hanging out and doing this really intense localized grazing, but must be population maps or things like that. Are there any working hypotheses for why that one county has such a...
Yeah, so there is a lot of, oh yeah, so question, so for some of the county by county differences in the changes in spatial autocorrelation or aggregation patchiness, yeah, so there are differences across those counties in terms of essentially the dynamics of who is coming in from the outside and accessing. And so the overall like population density of some of these areas has gone way up. It doesn't come out in the official statistics data because they're not registered there. They're visitors to that area. And so we can't get at it officially through those population data, but we can get at it in terms of some of the conversations with the agricultural administrators who are the ones who make those agreements with other states to say, we'll take your folks this year because we know you'll take our folks next year. Yeah.
I have one quick follow-up,
Okay.
which was, do you have a means or an idea about how to separate this population-driven effect versus these shifts in environmental conditions? Like I can imagine a hypothesis for how increasing frequencies of zoos or the winter storm effects also drive this decrease.
Yeah, so it's really tricky because they're also like sort of, yeah, coupled with each other too, in terms of the general sense of as conditions change, people move to where they're better and these things, right? And there was actually just a paper out with some colleagues of mine from Cornell in Science a couple of weeks ago where they tried to essentially use like econometrics and instrumental variable approaches to try to isolate those from each other. A big problem with that, they're great, I like them. A big problem on the paper is that there is embedded in that an assumption that people are still moving, and that's really but they're looking across the entire country where in some cases that is still the case, but where we're working, it really is not happening there. So it gets a little more complicated. Yeah, great question. Yeah.
Really interesting work. I had a question about the trend towards more fencing.
Mm-hmm.
And I feel like there may be two potential implicit components. It's either that people, or maybe there are more than two, but either that people view there's multiple types of actors, like I can, if I land correctly, it will be fine, as long as it's bad actors.
Mm.
Or people are trying to take more than their share of the land, so they can operate. Do we know, like, what's driving the push towards fencing?
Yeah, so the question is about sort of what's driving fencing. Is it trying to co-opt land versus trying to keep people away? And I think that's an excellent point. I think another way, a nuanced way of thinking about it is like enclosing something to like reserve it for the winter or something versus like exclosure, like keeping everybody like out. Or fencing livestock in versus fencing livestock out is another way. So there's a lot of nuance in that. And the other thing is just the scale of it. So from what we can tell, both in kind of looking at the imagery and then also on the ground, looking with our eyes, and then chatting with the ag administrators, is that the fencing is happening at 2 scales. So the reserve fencing, I'm just going to set aside this area for access for my livestock during the winter. That's happening at the scale of like a hectare or 2. Right? The sort of co-opting of land is happening over much, much larger scales. And those are the ones that they're worried about. Right? Not the need, not trying to keep folks out of, and their own livestock out of winter forage, but that is in some ways encouraged. Who knows at what scale that is actually sustainable, but it's the large areas that are keeping everybody else out so they can have it for themselves. That's the real part of the concern. Yeah, great question. Hi, Vanessa.
Thank you for your talk. I was wondering if you look at how changing herbivory patterns, like all the animals like shape very different, and I was wondering if that also impact like some of the changes in like composition and structure of the areas, and maybe how people are looking at that, like goats eat like everything, and literally everything destroyed all.
Great, thanks for asking. So this is where I get up on my soapbox and ask everyone not to buy cheap cashmere sweaters during the holidays. Don't buy quince. Can I say that here? So there's a huge global demand for cashmere right now, and that is driving a lot of that increase in goats. And goats are really heavy grazers. They will eat plants down to the roots, and they have a heavier toll, broadly speaking, depending on how you manage them, yada yada, than things like cattle. So yeah, particularly in areas where the goat numbers are really high, that's one of the big concerns, is that just their grazing behavior is different. So it's not so much about the numbers, but the composition of the herds. Yeah.
So it's your impression that it's driven by demand for cashmere, not saying we have more degraded landscapes, I'd rather have a more generalist grazer?
So I can see both. Yeah. No, there's a market for it. Yeah. So, but there isn't a great market. So the sort of initial processing facilities that you might want in order to like refine it to get a higher quality, there's basically just like they're buying everything in bulk. So the more you can produce, there's not a market for like, except for in niche cases, there's not a broad market for high quality. It's just quantity. And so that's driving it as well. So, yeah. Can I take one more?
Well, I was going to ask you if you could give us a really quick elevator pitch of the pollinator forest management, just so that we can hear a brief nugget, and then maybe take Sarah's question.
Sure. So we all know that pollinators are, wild pollinators are in decline across much of the world. One of those places is where we think is happening, the data suggest, is in northern India, where there are a large number of, up in the sort of low Himalayas, one of the big sources of livelihood is apple farming, and they largely rely on wild pollinators to pollinate those apples. And the production has been declining over the past decade or so. Conflicting ideas about how much of that is climate change versus supply of wild pollinators. We've done some initial work there that suggests that there is pollination deficit happening there, so there's not enough pollination happening. So people talk about wild pollinators as this common pool resource that we all sort of share and sort of receive benefits from. There's very little evidence in the world writ large of them actually being managed in such a way as we think of common pool resources, right? With like norms and institutions and collective action around them. And there's also, and some of that might be because it is just such a new issue, right? But also because there are like certain material constraints, particularly in the case of places like India, where people are working in these very small margins, that is just not, like, choosing not to spray pesticides, right, is just not an option. And so we're looking at to what extent I'm sorry, this is getting a little jumbled, but this is not a very good elevator speech. We're looking at the extent to which sort of on-farm behaviors versus the sort of surrounding landscape context might be contributing to declining pollinator abundance on these apple farms, specifically looking at forest degradation and doing some LiDAR work to get a kind of forest structure out of, and doing some forest structure wall-to-wall mapping there to understand how much is it just a lack of available pollinators versus kind of killing them once they get there, and then trying to understand like what is the potential for collective action around wild pollinators. We know a lot about how collective action institutions for common pool resources exist, or how they work for resources that have been managed that way for a really long time. Community fisheries and community forests and rangelands, right? They have these like classic institutions, but there's very little theory about how these institutions emerge for kind of novel collective action resources or common pool resources. And so we're, from a theoretical level, we're trying to kind of play with that. And then from a like sort of more applied level, they're sort of thinking about, okay, well, you know, if we're only focusing on-farm behaviors, but really like it's the forest management around these farms that actually needs to change in order to provide the habitat and the forage resources, then, you know, maybe we need to be thinking at different scales. So that's the long elevator pitch for that. Laura. So the aggregated statistics kind of yeah. So those like trend values, yeah. But visually it's all there, yeah.
Okay, so
they were seeing those.
They were seeing what they would expect to see.
They were seeing what they would expect to see on the maps, and they were very confused by these figures that we included to sort of generalize, right? And they were like, why does this say there's no change? I know there's change. I can even see on your map that there's change. Why does this say that there is no change over time? Yeah.
I can see that challenge as like the experts coming in with data.
Right.
Right, and if that's contradicting what their local knowledge is, like how that would play out when you're trying to collaborate and work.
Exactly, yeah, and when they're saying like, well, can we get, you know, can you give us some summaries or some data that we can take for these other reports, and, you know, well, yeah, let's think about what would be more useful than these like aggregated metrics. Yeah, they won't tell the story.
Great. Well, why don't we stop there? And before we thank Ginger, come join us at lunch if you have more questions. It seems like there's a lot of crowd questions. And then we'll also have a happy hour at 4 if you want to just come casually chat with Ginger later today. So looking forward to you joining us. And let's thank Ginger for a great talk.
Thank you for the questions.